Hello, YouTubers, and welcome to Level-Headed News. This is your host, Brenda. I have 4 articles for you in this episode, and all 4 of them are in the video in URL form for you to take a look at your leisure. The first one here, this is all scientific and space type news. The first one is off of Science Alert. It says, found a metal that conducts electricity but not heat. Researchers have identified a metal that conducts electricity without conducting heat. An incredibly useful property that defies our current understanding of how conductors work. The metal contradicts something called Pare's law. It's that good conductors of electricity will also be proportionally good conductors of heat. Monitors and appliances get so hot when you use them regularly. The U.S. has shown that this isn't the case for metallic dioxide, or VO2, a material that's already well known for its strange ability to switch from see-through insulator to a conductive metal of 67 degrees Celsius or 152 degrees Fahrenheit. This was totally unexpected finding, says lead researcher from Berkeley Labs Material Science Division. Drastic breakdown of textbook law that has been known to be robust for conventional conductors. This discovery is of fundamental importance for understanding the basic electronic behavior of conductors. Not only does this unexpected property change what we know about conductors, it could also be incredibly useful. The metal could one day be used to convert wasted heat from engines and appliances back into electricity, or even create better window coverings that keep buildings cool. We already know of a handful of other materials that conduct electricity better than heat. Those properties at temperatures hundreds of degrees below zero, which makes them highly impractical for any real-world appliance. Vanadium dioxide, on the other hand, is usually only a conductor at warm temperatures, well above room temperature, which means it has the ability to be a lot more practical. Bizarre new property, the team looked at the way that electrons move within vanadium's crystal lattice, as well as how much heat was being generated. They found that the thermal conductivity that could be attributed to the electrons in the material was 10 times smaller than that amount predicted by the Wiedemann-Franz law. This appears to be the synchronized way that the electrons move through the material, moving in unison with each other, much like a fluid, instead of as individual particles like in normal metals, said Wu. For electrons, heat is a random motion. For heat efficiently, because there are so many different possible microscopic configurations that the individual electron can jump between. Coordinated marching band-like motion of electrons in dioxide is detrimental to heat transfer, as there are fewer configurations available for the electrons to hop randomly between, he added. Interestingly, when the researchers mixed the vanadium dioxide with other materials, they could tune the amount of both electricity and heat conduct, which could be incredibly useful for future applications. For example, when the researchers added the metal tungsten to vanadium dioxide, they lowered the temperature at which the material became metallic and also made it a better heat conductor. Vanadium oxide could help dissipate heat from a system by only conducting heat when it hits a certain temperature. An insulator. It also has the unique ability of being transparent to around 30 degrees Celsius or 86 degrees Fahrenheit. Infrared light above 60 degrees Celsius or 140 degrees Fahrenheit. Transparent to visible light. It could be used as a window coating that reduces the temperature without the need for air conditioning. It can be used to help stabilize temperature, said one of the researchers, Fan Yang. By tuning its thermal conductivity, The material can efficiently dissipate heat in the hot summer because it will have high thermal conductivity, but prevent heat loss in the cold winter because of its low thermal conductivity. A lot of research needs to be done on this puzzling material before it's commercialized further, but it's pretty exciting. These bizarre properties exist in a material at room temperature. And this research has been published in Science magazine. So have that. The next one we have here is off of NE News, and it says fuel found beneath containment vessel at Fukushima plant. Reactor no longer there. Search barely begun for fuel that burned through. Workers probe underwater below plant for molten cores. And there are pics and videos in this article if you want to pull it up to take a look at them. It was January the 30th, so 2 days ago. Nuclear fuel debris sighted under damaged Fukushima reactor. Found beneath the plant number 2 reactor nuclear fuel. TEPCO found a black mass on a grating structure just beneath the containment vessel. Will be deployed to better understand where the nuclear fuel debris is located. Condition of the melted fuel has remained unknown. Images showed black mass and deposits accumulating inside the outer primary containment vessel. If the deposits are fuel debris, it means fuel melted through the pressure a container that is supposed to hold the fuel. The primary containment vessel appears to be substantially different from its original state. Conditions. In some areas, the substance had accumulated a few centimeters thick to form a chunk grid squares. Some parts of the grating were distorted or no longer there in the heat during the accident. Fuel debris possibly found below the reactor at Fukushima number 1. Black lumps that could be melted nuclear fuel are visible Monday at the bottom of the reactor number 2's containment vessel at the Fukushima number 1 power plant. Monday found that it may be melted nuclear fuel debris inside reactor 2 at the Fukushima plant. It's difficult to clearly identify what they are, said Okamura, general manager of TEPCO's nuclear power plant, during an evening news conference. Lumps that looked like something that had melted and then congealed, sticking to parts of a steel grating area at the base of the containment vessel. TEPCO found form of sediment under the number 2 reactor of its Fukushima number 1 nuclear power plant. Says TEPCO has failed to establish the location of the melted fuel rods in the other 3 damaged reactors at the plant. Utility has been developing robots that can swim underwater and negotiate obstacles in damaged tunnels and piping to fuel rods. But as soon as the robots get close to the reactors, the radiation destroys the wiring and renders them useless. Finds possible nuclear fuel debris. The substance is so toxic that even robots designated to probe the underwater depths beneath the power plant crumble and shut down. It said a remote camera appeared to have found debris beneath the badly damaged number 2 reactor, where radiation levels remain dangerously high. Begun for fuel that burned through the bottom of the reactors. So have that information that was taken from several sources, RT, The Guardian, Bloomberg, so we know on the nuclear reactor. The next one we have here is off of dailymail.co.uk. Says, could we have limitless energy in 13 years? To put fusion power into the grid. Tokamak Energy's device uses magnets to heat plasma to 15 million degrees centigrade. claims that its spherical design is a fast. It is working on a nuclear reactor that it says will be built by 2025. In the race to end the world's reliance on fossil fuels, power firm has put forward the most ambitious timeline yet. It plans to start operating its fusion reactor this spring and claims that its first commercial prototype will be built by 2025. The size of other nuclear reactors uses, I don't know, it's got something over top of it here. Spherical tomahawk, which as the fast route to fusion. There we go. The bold claims come from David Kingham, Tomahawk Energy, who was speaking at the International Energy Agency meeting last week. The firm's reactor will use spherical an experimental machine designed to harness energy of fusion, unlike other forms who are using more Tomahawks. Mr. Kingham said by pursuing this route, fusion researchers around the world, including energy, are developing new materials and technologies to help us get fusion power into the based Tomahawk Energy's technology revolves around high temperatures superconducting HTS magnets, which allow for relatively low power and small sized devices, but high performance. World's first Tomahawk with HTS magnets, Tomahawk Energy's second reactor, 9 hours of continuous plasma, was a world record. Mr. Kingham said the plasma is where the fusion reaction takes place, and its stability is crucial. On its next ST40 reactor, which it claims will produce plasma temperatures of 15 million degrees hotter than the center of the sun. And then there's an insert here. It says, what is Tomahawk? Tomahawk is the most developed magnetic system and is the basis for design fusion reactors, contained in a vacuum vessel, which is then heated by driving a current through it. Sets the magnet creates a field in both vertical and horizontal as a magnet cage to hold and shape the plasma. The heating plasma current supplies a third of the 100 million centigrade required to make fusion occur. Additional plasma added when neutral hydrogen atoms are injected at high speed into the plasma, ionized and trapped by the magnetic field. Down, they transfer their energy to the plasma and heat it. Are also induced in the plasma by external coils. The frequencies are chosen to match regions where absorption is very high. In this way, large amounts of power may be transferred. The next article that I have for you, I thought this one was fun. This is off of space.com, and it's called 13 Ways to Hunt Intelligent Aliens. No intelligent aliens? Really? Where are all the aliens? Probed, exterminated, assimilated, infected, invaded, or abducted by now, shouldn't we? My paradox ponders to the lack of evidence of another transmitting intelligent civilization. Of all the stars and all the galaxies in the universe, you'd think one intelligent would have bothered to call by now. The in stellar do not call list, or we're the most advanced life form out here, or even scarier, we're the only life form out here. Channel says, are we alone? Extraterrestrial life is one of the most profound things species can do, but as any other life beyond Earth's shores has yet to be discovered, the search for extraterrestrial intelligence, or SETI, hard sell. Still, the search continues, and scientists are thinking up more and more extreme ways to fine-tune our high-tech array of astronomical instruments to detect intelligence in the stars. In wonderful ways, science hopes to snare an intelligent alien. See if we can get this to. Okay, well, it's not cooperating with me. What's going on? I'm waiting for the hamster. Little buddy. Okay, well, that's not working. I don't know how to get it to go. Okay, we'll try this. Sometimes you have to reload it to get the hamster to kick into gear. Let's see. Come on, hamster. Poor little guy. Okay, well, shoot. I'm here. There we go. No, I think I was right the first time. Of technology, don't you? Maybe the aliens are messing with it. They don't want me to. What do you think? Oh, come on. Gee whiz. Well, well, I thought it was going. And we're waiting for the hamster. I see the little thing going round and round, so I know it's trying to bring it up. But steady candidates. Here we go. The main assumption we have to make is that our hypothetical page jumps. Isn't that great? I think the aliens are messing with me here. Oh, gee. Beam me up. Oh, God. Feast or famine, chicken or feathers. It goes one way and then it goes the other way. On. Well, I don't understand why this is not working better than it is. There, I think we got it now. Kepler's SETI candidates. The main assumption, I talked too soon, because I said that, and then it scrolled. I think the aliens are having fun with me. Well, I'll tell you what. One of these ways that we can have contact with intelligent aliens. And I guess if you find out what they are, you can pull up that URL and check them out for yourself, because it's not going to cooperate with me. It don't want me to contact them. So let's see if you have any better luck with it than I'm having. And that will conclude our episode for today. If you like what I'm trying to do here, in spite of the aliens and in spite of my hamster that's about to die, give me a thumbs up and let me know. And share it on your social media so everybody gets to have some fun with this. Done that yet, because you never know what the hell I'm liable to do. We'll see y'all later. Have a great day.